Yes, here. Yes. So we are discussing about linear permutation. In linear permutation, these three are very, very important arrangements. The first one is arrangements, sit together arrangements. The second one is specified order arrangements. And the third one is specified together arrangements. In the previous session, we already discussed about the definition of permutation and a derivation of the formula NPR and the properties of NPR and some simple applications. Now, these are the three very, very important arrangements in the case of linear permutation. We already know what you mean by a linear permutation. Linear permutation means if the objects are arranged in a horizontal line, either from left to right or right to left, then such type of arrangement is called linear arrangement. So especially the sit together arrangement is okay, no problem, we can do it very easily. But the specified arrangement, you should be very careful about these two arrangements. Most frequently they ask in MSET especially and JEE Mains, national level exam also, there is a chance of getting this type of arrangement, the questions on this type of arrangement. So let us see in detail. So let us discuss these arrangements in detail with a good example. Now see, first I want to explain about this sit together arrangement. Now I want to arrange first one is this sit together arrangement. It's very, very important. Let me explain. Now I'll give an example so that you can understand clearly. Yes, here. There are 4 boys and 3 girls in a class. Let us suppose. Consider 4 boys and 3 girls in a class. It contains so many boys and so many girls. Now, there are 4. Consider the 4 boys and 3 girls in a classroom. I want to arrange in such a way that all the girls should come together. All the girls should come together. Together undali. All the girls should come together. Just let me explain how you can. There are 4 girls, 4 boys and 3 girls in a classroom. I want to arrange in such a way that all the girls are together. All maybe boys also you can take. All girls together. Yes, how can you do this? Yes, yes. You see here, you consider these 3 girls, G for girl, as one unit. You pack these as one unit. You consider these 3 vowels as one unit. Okay, now you consider these 3 girls as one. And now there are remaining 4 boys. This B1, this B2, this is B3, and this is B4. Total, if we take 4 boys and 1 unit of girls, total how many we have? 5 objects you have. 11. There are 5 objects you have. There are 4 boys and 3 girls. Now, I should arrange in such a way that all the girls should come together. Okay, now all girls should come together. So whenever you want to together the objects, those objects is considered as one unit. You consider these objects as one unit. Now the remaining 4 boys and 1 unit of girls. Total there are 5 objects are here. Total there are 5 objects are there. So these 5 objects, they can be arranged in 5 factorial ways. No doubt. These can be arranged in 5 factorial ways. And also if you see, there are 3 girls. Let us suppose G1, G2, G3. G1, G2, G3. This is one of the arrangements. This is one of the arrangements. Yes, here. Now, G1, G2, G3. For this arrangement, you'll get 5 factorial ways. Okay, you first fix G1, second fix G2, third you fix G3, and you consider, you move this packet, this 1 unit of girls like this. Okay, now, what about this unit? B1, B2, B3, B4. This is one of the 5 factor arrangements. B1, 1 unit of girls. These are 1 unit of girls. Okay. Yes, sir. B2, B3, B4. Like that, if you arrange, there will be 5 factor arrangements you get. You see, whatever you're fixing the 1 unit of girls, there are 3 factorial ways we can arrange that. This is G1, G2, G3. This is one of the arrangements. Or you can also write G1, G3, G2. This is one way. And then G2, G1, G3. Alage G2, G3, G1. Like this you can arrange so many ways. Like this you can arrange so many ways. So like this you can arrange. So now, how many ways you can arrange them? This G1, G2, G3, they can be arranged in 6 ways. For each arrangement, you'll get 5 factorial ways, 5 factorial arrangements. Okay, I'll try to explain in detail. Yes, let me explain. Yes, yes. Notes here. Now, I want these 3 Gauss should come together. You consider these 3 Gauss as 1 unit. And now, total 5 objects are there. They can be arranged in 5 factorial ways. But here, 3 Gauss you're saying, G1, G2, G3. So they may be internally arranged like this, G1, G2, G3, or G1, G3, G2. Yes, G1, G2, G3. Next, G2, G1, G3, or G2, G3, G1, or you can also write G3, G1, G2, or you can also write G3, G2, G1. Total 1, 2, 3, 4, 5, 6. There exists total 3 factorial arrangements we got. For every arrangement of this one, you'll get 5 factorial. For this one, you'll get 5 factorial. For this arrangement, you'll get 5 factorial, 5 factorial, like this you're having. Since there are 6 arrangements, you'll get 6 into 5 factorial. 6 is nothing but 3 factorial into 5 factorial ways. Okay. So, you fix this order, you'll get 1 5 factorial. You fix this internal 3 Gauss, we consider as 1 unit. You fix this order, you'll get this 5 factorial. And internally, these many ways you can fix. For each fixing of the arrangement, you'll get 1 more 5 factorial. That is very important. Okay. So simply what we do is here. So total, you're considering as 1 unit of Gauss plus 4 balls, total 5. They can be arranged in 5 factorial ways. And these 3 Gauss internally, they can be arranged in 3 factorial ways. For each of these are called internal arrangements. There are 6. For each internal arrangement, you'll get 5 factorial. There are 6 internal arrangements. You'll get 6 into 5 factorial. So these many ways we can do it. This is what we call total number of ways we can do it. This is what. Now, there are 4 boys and 3 girls. I want to arrange in such a way that all girls together. Girls anta ok chota undali. You consider these 3 girls as 1 unit. In muguru girls kalpi 1 unit anukunnam. These are 4 boys. 4 boys plus 1 unit of girls, total 5. They can be arranged in how many ways? 5 factorial ways. Arrange. Yes. So for every internal arrangement, you will get 5 factorial. So since these 3 Gauss, they can be arranged in 3 factorial ways. These are nothing but 3 factorial ways, 6. So for each arrangement, you will get 5 factorial. Since there are 3 factorial internal arrangements, you will get 5 factorial into 3 factorial. I am using multiplication by using counting principle because this is only the arrangement, but you are missing this internal arrangement. So you can arrange this internal arrangement. This is one operation. This is another operation. These 2 must be done successively. Then only work will complete. By using counting principle or fundamental principle, since work is incomplete, you are getting multiplication. Yes, very, very important. Right? So, right? Yes, here. There are 4 boys and 3 girls. I should arrange in such a way that all girls should come together. You consider these girls as 1 unit, 3G as 1 unit, 3 girls and B1, total 5. This 1 unit of girls you're having. So you can arrange in 5 factorial ways. These 3 girls, G1, G2, G3, these many ways. These are the internal ways you can arrange these 3 girls. Okay, this is 6 ways. It's nothing but 3 factorial. For every arrangement, you'll get 5 factorial. Since there are 3 factorial arrangements, you'll get 3 factorial into 5 factorial ways. Why I'm using multiplication? By application of counting principle. Okay.
Yes.
So this 5 factorial operation is one operation. Internal arrangement is another operation. These 2 must be done successively. Then only work will complete. Okay. Here, if you see these 5 factorials, here we have to add because internal arrangement fixed, 1 5 factorial. Work is completed. This is internal arrangement, 5 factorial. Work is completed. Here you should add. Here you should multiply. Remember, very simple. Work is incomplete, do multiplication. Work is completed, do addition. This is what you get. 5 factorial ways. In between, you're having 5 factorial into 3 factorial ways you can do it. Yes. 5 factorial, you already know. This is nothing but 120 into 6. Total, there are 720 ways we can do it. That's it. Got it. Yes. Not only this one, so many examples. Just the previous problem you're having, there are some letters contain vowels is given. I want arrange in such a way that all vowels come together. Yes, we can do it. Very easy.
Yes.
Okay. Right now, here. This is one of the examples. Arranging the objects seated together. Okay. Right. Next.
Done, sir.
Yes. Next one. Right. Yes, yes. Another example also we can do it. So many examples we can do it. So many examples. For suppose, let us take example 2. Let us take example 2. Let us see the picture letters. There are pictures. Now, I want to arrange the letters of this picture. So if you see the vowels, these are vowels here. What are vowels here? I, U, E. These are the vowels. What are the consonants? P, C, T, R. These are the consonants. Just let me explain. So in the letters of the word picture, there are 3 vowels and 4 consonants. Listen. There are 3 vowels and 4 consonants. So in the letters of the word picture, 7-letter word picture, there are 3 vowels and 4 consonants. No problem. I should arrange in such a way that all vowels should come together. I should arrange in such a way that all vowels should come together. Very simple, we can do it. Now, you consider this IUE as one unit. It's very simple. Plus remaining PCTR. Total 4, 4 plus 1. How many? 5. 5 objects you're having. So they can be arranged in how many ways? 5 factorial into
3
these
factorial.
vowels internally they can be arranged in 3 factorial ways of this question. So this is equal to 120
into 6, 720 base.
720 ways we can arrange them very easily. This is what you get. Got it? This is called sit together arrangement. There are 7 letters in the word picture. These are the vowels and these are consonants. I should arrange in such a way that all vowels should come together. You consider all these vowels as one unit. And PCTR, 4 consonants and 1 unit of vowels, total 5. They can be arranged in 5 factorial ways. IUE, internally they can be arranged. Internally they can be arranged in 3 factorial ways. And IUE, this is one arrangement. I can also write IEU, another arrangement. UIE, UEI. For each internal arrangement, you will get 1 5 factorial. So since there are, you're having 3 factorial internal arrangements, the total number of ways is equal to 3 factorial into 5 factorial ways. So one operation can be done in 5 factorial ways. Internally and another operation can be done in 3 factorial ways. Total is equal to 5 factorial into 3 factorial ways we're having. So 120 into 6, total 720 ways we can do it.
1 minute, sir.
Yes. Okay. Next. So like this you can take so many examples. Like this you can give so many examples. Like this you can give so many examples. Vowels should together, or consonants should together. Anything you can take. Boys should come together, or girls should come together. Like that. There are 100 students in a class. I want only specified students A1, A2, A3 should come together. You can arrange very easily, no problem. So whatever the objects you want to arrange together, you consider them as one unit and you tie them. They're having 4 maths books, different subjects, 4 maths books and physics books and chemistry books. I want to arrange in such a way that all maths books should come together. Like that also you can arrange very easy. Okay. Yes, total consider as one unit, total 5 factorial into its internal arrangement. That's Okay, right. Now, another one is here. Now, the second arrangement, specified order arrangement, is very, very, very important. So, first time it's very difficult to understand, but once you understood, it becomes very simple. Every time we used to recollect. Okay, this is about the specified order arrangement. You need more practice to understand this concept. This is second one, specified order. What do you mean by specified order? Yes. Yes, let me explain about the specified order. Right. What do you mean by this specified order? So let me explain. I try to explain in detail. What do you mean by this specified order? Specified order. Yes, let me explain. You see, there are 10 students, A1, A2, A3, and so on. Consider 10 students in a class. Consider A1, A2, and so on, A10, 10 students in a class. Right. So I want to arrange in such a way that, right, A1, rank of A1, let us suppose, rank of A1 is always above A2, rank of A2 is always above A3. So what do you mean by this? Let me explain. The results of 10 students we got, so that, right, we got so that the rank of A1 is always above A2 and the rank of A2 is always above A3. Then what do you mean by this? Try to understand the meaning. Okay. I want to arrange these 10 students in such a way that the rank of A1 is always above A2. The rank of A1, the rank of A1 is always above A2, and the rank of A2 is always above A3. How we can arrange? So let me explain. So there are 10 students, right? They got the rank like this. You know only this information. The rank of A1 is always above A2, and rank of A3 is always above A2. What do you mean by this? I try to explain. This is here. You see, the rank of A1 is above A2 and rank of A2 is above A3. Yes. What do you mean by that? So what's the actual meaning of this? Yes. If you understand that meaning, you understand the specified order definition. Yes.
Means the rank A1 is more greater than A2.
Yes. 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 Like this. Okay. That means what actually it means here, there are 10 students. Okay. There are 10 students here. Right? Rank of A1 is above A2, rank of A2 is above A3. And above A1, there are many students. In between A1, A2 also many students. Or in between A2, A3 also many students, and A3 also many students. No problem. And it may be successive also. A1, A2, A3. It may be successive also like this. Before and AB also. They may be together also. No problem. There is a successive in between. Okay. This is, first suppose you are having above 11, yes, 7, 8, 9. At 7th rank, 8th rank, 9th rank. Consecutive also may be there. Later, if you have here, this is 10. This is 5. This is 1. No more before A1. No more. So try to understand this one. That means the rank of A1 is always above A2. Okay? If for suppose, answer 1, 1, 5, 10. It's no problem. Yes, like this. So many students may be there. So rank of A3 is 1, rank of A2 is 5, and rank of A1 is 10, and so on, like this. And sometimes it may be like this also. Yes, here. This is 3, 5, 7. So in between before and there are 2 like this. You're having like this. Yes. Try to understand the meaning. Rank of A1 is always above A2, and the rank of A2 is always above A3. And you see here, A3 pine A2. If you give first rank to A3, the 5th rank goes to A2, and 10th rank goes to A1. It may be consecutive also. 7th rank is A3, 8th rank is A2, and 9th rank is A1. Like that you're having. Okay, they may be successive also. Yes, try to understand the meaning. Now, then this A1, A2, A3 are said to be in specified order. That's said to be in S order, specified order. They can be said to be in specified order. Yes. Just let me explain. What do you mean by this? Rank of A1 is always above A2, and rank of A2 is always above A3. This is what actually means. They may be consecutive, next to each other, or there may be some students in between these two, in between above, like this. That means what it says is the rank of A1. You see, this is 10th, this is 5, this is 1, but it should not be reversed. So A2 should be above A3 only. A1 should be above A2 only. You see, after 1 you got 5, and slowly you are increasing the rank here. So 1, here 5, it is 10. And it is not possible that A1 rank is less than A3, or A1 rank is less than A2. Always A2, whatever it may be, A2 should be above A3, and A1 should be above A3. That's what we say. Okay, I'll give one more example that you can understand clearly. Yes, I'll give an example that you can understand. This is rank of A1, A2. Then A1, A2, A3 are in specified order. This is my order arrangement. Specified order means this is my order arrangement. So there are 10 students. Here clearly, very clear, rank of A1 is above A2, and rank of A2 is above A3. So what actually it means is, A1 rank is always above A2, and rank of A2 is always above A3. And it should be more than, A2 rank should be more than A3, and A1 rank should be more than A2. Or they may be consecutive
Yes,
also.
sir.
6, 8, 9. 8 is greater than 7. 9 is greater than 8. They should be. But it should not be like this. For suppose you are having like this. It should not be like this. And A2, A3, A1. This is wrong. This is, for suppose this is 5. Let us suppose this is 7 and this is 4. This is wrong. This is wrong. Okay. So that means the rank should be increasing. The rank should be increasing. And in no one of the cases, in any one of the cases, A1 should not be below A2, and A2 should not be below A3. Then such a type of order, we call it as a specified order. Specified order means this is my order, I specified. That's all. I specified this order. Okay, the rank of A1 and is always greater than A2, and rank of A2 should be greater than A3. Then no doubt A1, A2, A3 are in specified order. First, identify what you mean by specified order, and then we go for that arrangement. Yes, now here. I'll give one more beautiful example so that you can understand. I'll give the same thing, but I change the words. Okay. Yes. 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 There are CM and Home Minister, and remaining there are 3 cabinet ministers we are having. There are cabinet ministers. There are 5 members are there. There are 5 members. CM, Home Minister, and 3 remaining cabinet ministers are there. Totally there are 5 persons in a meeting, in a public meeting. Let us suppose there are 5 members in a public meeting. Okay, 5 members in a public meeting. Try to understand. I want to arrange the meeting order in such a way that CM always speaks. CM always speaks after Home Minister. After Home Minister. Just let me explain. After Home Minister. What do you mean by this? So I want to arrange CM, Home Minister, and 3 cabinet ministers in such a way that CM always.
Sir, I think it's Home Minister talks always after CM.
Okay. CM always speaks after Home Minister. Then what you can say? Then these 2 objects are in specified order. No problem with the remaining 3 these cabinet ministers. These cabinet ministers, no problem. So I explained, I have to arrange. I want arrangements in such a way that, for suppose, let us suppose you are the personal secretary of CM. You are the personal secretary of CM. I want to arrange a meeting order in such a way that CM must speak after Home Minister. Then definitely this CM and Home Minister must be arranged in this specified order. And I will explain. Yes, here. So M1 Minister may speak after CM, right? After CM, M2, I mean, right, you see, M1,
After M1, M2,
Home
sir.
Minister, okay, next, M2, next, CM, M2. Which one? It is in first place is one, First Minister, M1 Minister, second, Home Minister, third, again Cabinet Minister, fourth, CM, and fifth also Cabinet Minister. You see, CM will speak after Home Minister. Let us suppose this is an order. I arrange like this, and I arrange like this. So I arrange in such a way that, right, CM should speak only after HM. You see, CM is in fourth place, HM, Home Minister is in second place. No doubt they are in a specified order. Okay,
Yes.
this order is satisfied. For suppose, if you make it reverse, is it okay?
No, sir. Because the order gets disturbed.
Right. So this order is disturbed because Home Minister, CM should speak after Home Minister, but here reverse. Home Minister got the order after CM. So this is the wrong way. You have to go. This is what you have to go for. Then no doubt that CM and Home Minister are in specified order. These are the things you must know. What is the meaning of this specified order? Specified order. This is an order specified by me, isn't it? For suppose there are three cabinet ministers, a CM and a Home Minister. They used to give a meeting in a public. They used to go for a public meeting. So being a personal secretary of CM, I want to arrange the order of the meeting in such a way that CM should speak only after Home Minister. Then CM and Home Minister will be in a specified order. No problem with the remaining ministers. This is one of the ways we can arrange. This is one of the ways we can arrange. Like this arrangement, how many number of arrangements we can arrange? That is what we have to know now. Let us see the proof. Let us see how many arrangements, this type of arrangement, how many ways we can do. It's very simple. Yes, I'll explain. Yes, see. Now, how we can arrange? So there are CM, Home Minister, and three cabinet ministers. I want arrange in such a way that right, CM always speaks after Home Minister. Yes. CM always speaks after Home Minister. Yes, see. Arrange. You see. Now, we take a paper. Take a white paper. Let us assume you are the personal secretary of CM. Let us assume you are the personal secretary of CM. Now, how many persons are there? 1, 2, 3, 4, 5 persons. You gave the number.
5 persons.
1, 2, 3, 4, and you gave the number like this. Yes, now. It's very simple, you see. Now, I'm saying about the arrangement, how to arrange two objects in a specified order. So these are the CM always speaks after HM. And I kept all these CM and Home Minister in a specified order. And no problem with the remaining minister. They can speak anywhere. Anywhere they can speak. Now, how to arrange this one? Yes, let me explain how you arrange this specified order. Very, very important, but very simple. It's all very, very simple you can do. Now you take a white paper and you give 5 numbers. Because 5 objects are there, you give 5 numbers. Okay, you give 5 numbers. Make sure that CM should always speak after Home Minister. And a CM
Then
order
Home Minister comes first, then CM comes.
Right. So after Home Minister only this CM will speak. Then what you can do? First, you see here. First, you keep this CM and Home Minister aside. Okay, you keep this CM and Home Minister aside. First, you keep aside. Now, you keep aside. Right. Now, how many ministers are there here? How many ministers are there?
3.
Cabinet ministers are 3. How many places you have? 5
5,
places.
3, 5p3.
So 5 places, these 3. First, these 3 ministers should be placed in any one of these 5 places in how many ways? 5p3 ways.
5p3 ways.
Am I right? I can arrange them in 5p3 ways. And suppose this here, minister M1 here. Let us one of the 5p3 arrangements, M2, M3. So this, let us
But that
suppose
order cannot, because
let me
after CM.
Let me yes, let me explain. First, you keep the CM and home minister aside. No problem. Now, how many places are there? 5 places.
2.
First, arrange them
Yes.
other than the specified order objects. First, you arrange the objects which are not necessary to be in a specified order. You keep the specified objects aside first. To arrange these 2 objects in a specified order, you take the total places for the total objects, including CM and home minister. There are 5 persons, they used to give a space. You take these 5 places. You keep these 2 specified order objects. You want to have to arrange them, you keep aside. Now, in the total 5 places, you first arrange this minister. M1, M2, M3. This can be done in how many ways? 5p3 ways.
5p3 ways.
5 places are there. These 3 can be placed in 5p3 ways. You see here, there are 5 chairs in a theater. There are 3 persons. Go and occupy those 5 chairs. How many ways they can occupy? 5p3 ways. They can occupy in 5p3 number of ways they can occupy. Here also, 5 places. First, you place these 3 ministers in 5 places in 5p3 ways. No doubt. This first place in M1, third place M2, M3. This is one of the arrangement of 5p3. Am I right? This is one of the arrangement of 5p3. No problem. Now, how many places remains empty here? How many places remains empty here? 2 places. What are those? Second place and 4th place. Am I right? Those are 2 places remains empty. Am I right? So second
Yes,
place
sir.
and 4th place. Right. How many ways you can arrange? Now here. These 2 places should be filled by CM and home minister. Right.
Yes, sir.
Now, second place, what you have to write? The second place should give
CM.
as a CM place or it is a home minister's place. What you have to go? No, note that. CM always speaks after
First, second place HM will come, sir.
HM, home minister. The
Then
first place,
CM comes.
4th place will be CM. And it can be done only in one way.
One way.
That's all. Completed. That's all. 5p3. 5p3 means how much? You can say 5 factorial by 5 minus 3. That is 2 factorial, am I right? I can write like this.
Yes, sir.
NPR, n factorial n minus r factorial. 5 factorial by 5 minus 3. 2 factorial. Since 2 objects are in specified order, we got 2 factors here. Unknowingly. Is one of the way. It's very simple. It's very simple.